In this video, we'll talk about true weight and apparent weight. Remember, true weight is the object's force of gravity, and the object's apparent weight is the object's normal force. So let's say that you are 60 kilograms, are in an elevator that's accelerating upwards at 1.5 meters per second squared. What is your apparent weight? So here you are in an elevator, your feet are on the floor, you experience some sort of normal force on your feet. The force of gravity is pulling you down, and the normal force is pushing you up. So then our net force equation is F net equals Fn plus Fg. We can always substitute F net with mass times acceleration. Normal force is what we're looking for because we're looking for our apparent weight. And force of gravity we can replace or substitute with mg. But because the force of gravity is acting downwards, it will be negative mg. Once again, we're looking for Fn. So to isolate for Fn, we need to add mg to both sides. So we have mass times acceleration plus mass times the force of gravity, or acceleration due to gravity, equals Fn. Now let's substitute. We can factor out the mass as well. 60 kilograms times 1.50 meters per second squared. And because the elevator is accelerating upwards, this is positive, plus g is always positive 9.81, equals Fn. We solve, and it is 678.6 newtons, or 6.8 times 10 to the 2 newtons. And it's positive, so therefore it is up, which is good because the elevator is pushing you up. In this example, you're in an elevator and experience an apparent weight of 400 newtons. What is the acceleration of the elevator? So we have the same free body diagram. The force of gravity is pulling you down, whereas the normal force is pushing you up. Again, the same net force equation, F net equals Fn plus Fg. Remember, always substitute Ma with F net. The normal force, it says we're experiencing 400 newtons, plus the force of gravity we can substitute with mg, but again it's negative mg because the force of gravity is acting down. Let's substitute in some more numbers. 60 kilograms times A equals 400 newtons minus 60 kilograms times 9.81 meters per second squared. Solve for A equals 400 newtons minus 60 kilograms times 9.81, all divided by 60 kilograms. We do our math, and our answer is negative 3.14 meters per second squared, which really means it's accelerating at 3.1 meters per second squared down. And for a third example, we have a box in a freight elevator. Here's a box, here's our elevator, and the box experiences an apparent weight of 1,500 newtons while it's being accelerated up at 0.50 meters per second squared. And we're asked to find the mass of the box. Once again, our net force equation is Fn plus Fg. Fnet we can substitute with Ma. Fn we're told is 1,500 newtons plus the force of gravity. Force of gravity is mg. It's negative in this case because the force of gravity is acting down. And we're asked to find the mass of the box. Here, the mass is on both sides of the equation. Let's add mg to both sides so that they're on the same side of the equation. So on the left-hand side, we have ma plus mg equals 1,500 newtons. Factor out the m equals 1,500 newtons. Divide both sides by a plus g. A plus g. And now we can substitute in some numbers. Divide by 0.50 meters per second squared. It is positive because the question tells us it's accelerating upwards. Plus g is always positive, 9.81 meter per second squared. We do our math and find out the box is 116 kilograms, or 1.2 times 10 to the 2 kilograms.